Right. So we're actually not going to be using like a set of guided notes today because what I really want to do is do some like review for our quiz, also on the central limit theorem, which we will be using a lot of the time this class and the next couple of classes throughout the semester. So I want to make sure that it is solid in your heads. Also, the first semester I taught the central limit theorem. Like I gave a test and everyone got the central limit theorem question wrong, and that made me very sad. So now I'm just going to go overkill on the central limit theorem so we all get it right. So going over something too much is a lot better than going over it not as much. So this is why I harp on this topic a lot. Okay, so we talked about the central limit theorem last class, and first of all, I did give out a guided notes, even though we won't use it during this class. Is there anyone who needs a copy? All right. Okay, but in the beginning of the guided notes, I introduced a few symbols that we'll be using throughout the rest of the semester. And I think the symbols are kind of the most confusing part because there's so many different symbols and they look a little bit weird. So what I'm going to have you do is I have a bunch of descriptions up on the board. I have different symbols written on my post-it notes. I'm going to have you get into groups of maybe like 2, 3, or 4. I'll give you a post-it note and I'll have you put the post-it note on the description that best suits the post-it note. All right. Let's come up to the front here. We have one that doesn't have a post-it note, so it looks like one of them is not correct, but let's go through these. So far, let's start off with the easiest one. I think sample size. We have N. Does everyone agree that N stands for sample size? Yeah, N stands for the number of things, or like how many things are. So N seems about right. Next, we have the population mean. We have the Greek letter mu. Everyone agree that mu stands for population mean? Good. Population standard deviation. We have the O with the line on top, or a lowercase sigma. Everyone good with that one? Yeah. Yeah, I agree with that too. Okay. So done with the population. Let's go to our sample ones. The sample mean, I have X bar. Everyone agree? Me too. Okay. Sample standard deviation, let's skip that one since there's nothing on it. Next, we have the mean of the sample means, which was a little weird. But basically, with our example last class, we took a bunch of samples, all the possible samples in a population, and we found all their means, and then we found the mean of that, and that was the mean of the sample means. Okay. Now, the symbol I have written down here is mu with an X bar. Okay. Now, this is the correct formula for the mean of the sample means, and the reason it is the correct formula is because, well, it consists of two symbols, right? The main symbol is our population mean symbol, okay, which we usually use for mean, okay? And this symbol here is the sample mean symbol. Sample. So even by reading the symbol aloud, just by looking at what the symbols mean, it literally is saying the mean of the sample means. Okay, so that's how you can read it. Okay. Let's go to the standard deviation of sample means. We have a post-it note for S, and then we have a post-it note for sigma X bar. Is it the first one or the second one? The second one, right? So the standard deviation of the sample means is definitely going to look sort of like this one, since we're talking about sampling distribution here. But we will have the sigma symbol and X bar. Okay. So this is the standard deviation of the sample means. Just using the symbols for each. So what do you think sample standard deviation is going to be? S, right? So S is probably the lamest symbol for any of these, but that represents the sample standard deviation. Any questions on what these symbols are and what they mean? Okay, these are things that you have to know for the quiz and for the rest of the class. We will be using these very often. Okay. Am I okay to raise this? Okay. Get out of the way with the questions. All right. And because I have people on Zoom, yeah, okay, they can see that. I'm just going to be using this board, so I'm going to erase this real quick. All right, so I do want to go over what we did last class, which was the central limit. Central limit. Right. And this was, I said, like the most important theorem in all of statistics, right? If you ask any statistician, they would tell you that this is like the biggest thing in statistics that really matters. One, because it's really useful, and two, because we're actually going to be using this in the next section that we do on Friday. And it also plays a part in the section after that. So this comes up very often, and it's a little confusing. So in order to explain this, let's just go over what this says, and then we'll do some practice with actually using it in questions. Okay. So for the central limit theorem, one of two things had to be true, right? So we have to look out for the question if it says one of these two things. Can someone give me one of the two things, Claire?
It needs to be higher than 30, but the sample number needs to be higher
than 30. Good. The sample size, or n, has to be bigger than 30. Okay, so we need a large sample. So 30 or more things in our sample. Okay. What was the second thing?
There has to be normal or approximately normal.
Good. There has to be something in the question that says the population is normal, or some statisticians use the term approximately normal, which I don't really get, but that's because I don't have a degree in statistics. So we'll leave that to the statisticians. But the population is approximately, and all that means is it looks like a bell-shaped dish. Okay, it looks like a bell. If either one of these two things is true, then we can go on to the rest of the theorem. So if either of these is true, what the central limit theorem says is that the distribution, and distribution just means shape or how spread out things are, okay? The distribution of the sample means is normal. So all this is saying is if we did that whole example that we did on Monday, where we took a population and we found all the possible samples, found their means, and then found the means of those. Sorry, we found all the means. If we made a histogram of all those means, it would look like a bell. Okay, so it looked like that normal distribution. Furthermore, the central limit theorem also tells us about the mean of the means. So it gives us information about this funky symbol. And it also tells us something about this funky symbol. Okay. Can someone tell me the formula for the mean of the means? It's pretty easy. Not quite. It's actually just the mean. Okay, so the mean of the means is literally just the population mean. Okay, so that is the easy one. What was the formula for the standard deviation?
It's something over the square root of n.
Good. Do you remember what that something is? Standard deviation. Now, of course, it's the standard deviation, so it has to do something with that, right? And then it also has to do with the square root of it. All right. So this is what the central limit theorem says. We did some examples on how to apply this in a question, but I didn't let you on your own. So what we're going to do today is, let me turn this back on. Let's hope it actually turns back on. Okay. Maybe it'll come up soon. Okay. Okay. Hopefully this happens soon. Okay. And now. Now. Oh, it's coming. Okay, we are going to play a game. Okay. Now, I normally use Kahoot, but Kahoot is under a paywall right now, and that makes me mad. So
You have to pay for Kahoot now?
yeah, I have to pay. If I don't pay, only 10 people can join my Kahoot game. Other than that, I have to pay for stuff.
That's horrible.
I know. I actually asked the math department to pay for it, and they're working on it. So, but for now, we're gonna go on Nearpod, which is like great value Kahoot. So we're gonna do You're going to go to join.nearpod.com and type in this code.
Did you guys get to choose which mouse you guys are? Because there's like only two words in there, and I feel one or two of them have a very small population compared to all the pumpkins. Why are there so many pumpkins?
I'm gonna do a statistics activity on what people prefer.
I prefer no mouse. They're probably so cute without it. Look, another pumpkin.
Oh. All right, is everyone joined? All right. All right, let's start our first question then.